Mr. Farhan, sorry, we can hear your voice.
Hello, can you hear my voice?
Now, okay.
All right.
Now we can hear you.
Okay. Thank you, Zulaika, for the lovely introduction. Today, I'm Farhan. I'll be presenting a webinar about a Waveguide Iris Bandpass filter simulation using Ansys HFSS. So before we jump to that demonstration, this is all the Ansys product that we can provide to you. And my main is in Ansys Electronics. So inside Ansys Electronics, there are some products here. There are HFSS, Maxwell, SI Wave, iSpec, MotoCAD, EMA 3D cable, Q3D extractor, EMA 3D charge, and no-hits filter solution. So you can learn more about this in Ansys website /product/electronics. So for today, I'll be using Ansys HFSS. So what is Ansys HFSS? HFSS stands for High Frequency Structure Simulator. It is a general purpose full-wave 2D or 3D electromagnetic design and simulation tool for high frequency application. So some of the example of the high frequency application is antennas, microchips, filters, integrated circuit, print circuit board, radio frequency components, and microwave components. So for the waveguide filter simulation, it is used for signal processing. It is used in signal processing. So before we jump to what is waveguide filter is, I'll be showing you what are the application of signal processing. I've prepared a video for you, a short video for you to watch.
Video tak ada bunyi.
Oh, tak ada bunyi. Sorry, some of my colleagues said the audio is not heard. Let me repeat it again.
In our pockets. What is signal processing? Signal processing is a branch of electrical engineering which pulls meaning from the broad sources of data that are all around us. But what does that mean exactly? It means signal processing is at the heart of our modern world. Signal processing powers modern communications,
How can I help you?
modern entertainment, and tomorrow's transportation. Signal processing is at the intersection of biotechnology.
Voice print access.
Access granted.
It's in our social interactions, learning to anticipate our needs and emotions, helping us hear the world around us and to better understand it,
سلام چطوری خوبی؟ Hi, how are you doing?
to bring new life and help us heal. Signal processing brings the world to our homes, adds clarity, and puts it in our pockets. Signal processing documents our cherished memories, helps to keep us safe, and powers the world of finance. Signal processing, processing the future.
Okay, so now let's jump to the topic about what is a waveguide filter. So a waveguide filter is an electronic filter constructed with a waveguide technology. A waveguide are hollow metal conduits inside which an electromagnetic wave may be transmitted inside here. Filters are devices used to allow signals at some frequency to pass, which is the passband filter, while other are rejected, which is the stopband. So you can see from the picture, this is one of the theoretical design for a waveguide filter with the dimension here. Then inside with the waveguide filter, there are iris, which is this metal sheet, the sheet here. So what are iris? An iris is a thin metal plate across the waveguide with one or more holes in it. It is used to couple together two lengths of a wavelength and is a means of introducing a discontinuity. Some of the possible geometries are shown. You can see here. If the iris is placed at the side, the left side or the right side, it is like an inductive iris. If the iris is placed on top or bottom, it is a capacitive iris. And if it is placed at the top, bottom, and the sides, it is equivalent to parallel LC iris. So for the demonstration, I'll be simulating a waveguide iris filter. So firstly, for the geometry, this is all the dimension for the waveguide filter. So firstly, we're going to design the filter box using the modeling tool. Then we add the left and right iris. After we creating the geometry, we go to the simulation setup where we assign the conductive boundary for the box and the left and right iris, and we assign the wave part. And finally, we're going to get a result of the S parameter of the waveguide filter, and we can also plot and animate the electric field inside the iris waveguide filter. So now I'll be opening Ansys electronic desktop. So I'll be using Ansys electronic desktop 2023 R1. So firstly, we're going to create a HFSS design. by clicking on FSS and click on FSS. So we can see here, we can rename this project to Waveguide filter. And for this design, I'll be renaming it to Iris Waveguide. So if we expand this, we can see all the FSS workflow, which is the 3D component, the model, circuit element, boundaries, excitation, mesh, analysis, optometrics, result, port field display, field overlays, and radiation. And first of all, before we go to the geometry setup, what we're going to do is we change the units to inch and click OK. And we change the solution setup. So to change it, click on FSS and go to solution type here. So there are many solution type here, but for this demonstration, I'll be using the FSS network analysis with model terminal, and then with model instead of terminal, and then we click OK. Now, before we create the geometry, I want to set the local variables. So to create a local variable, we go to FSS here and click on design properties. And for the local variable, we go add. And for the local property here, we can see from my slides on this geometry, this is all the local properties, which is the ZWG, XWG, YWG, X iris, and Y iris here. So to set it up, let's first go to XWG, change the value to 0.9 inch. And then we add for YWG, Y waveguide, so 1.5 inch. Okay. Z waveguide. The value is 0.4 inch. Click OK. And then for the iris, X iris, 0.2 inch. And Y iris, 0 inch. You click on apply and click on OK. And then if if you want to see the variable again, you can click on this iris waveguide here, and it will list all the variable that we can use inside this design. So now we're going to create the waveguide box. So we simply click on this modeling tool or the draw box, and we just first create a box, and then we click on this. We create a box one and create box here. So firstly, I want to change the name to waveguide box, and we change the transparency to 0.8, and we don't need to change the material. Click on apply, and if we click on this create box, it will show the position and the dimension of the box. So we want the box to be positioned at the middle, so we change it the position to minus XWG over 2 and minus YWG over 2. And then for the size, X size is the X waveguide. The Y size is YWG. and the Z size is ZWG. Can click apply. You can see it's already changed to the dimension that we wanted. So why do I prefer this method using the variables? So that if you want to extend the size of the box and you want it to be always at the center position, so you just click on the variable here and you just change the YWG here to make it longer. For example, let me show you. If you change it to 2, see, the box is still at the middle and it will be at the center here. So let me change it back to 1.5 inch. Now I want to add the iris. So to do that, firstly, I want to change the plane. This one is XY plane. I want to draw on the XZ plane. So now I can draw inside on the XZ plane. So we click on the draw rectangle here, and we click make a rectangle first, and then you can change the name to left iris, and you don't need to change the color of the material. And if you click on the create rectangle here, you can see all the dimension and the position. So for this left iris, the position is minus XWG over 2, which is in the middle. And then for the Y position is the Y iris and 0. And for the X size is X iris, and Z is the Z waveguide. You click on that, you can see the rectangle already changed to our dimension. Now we create the right iris using the same method. And we change the name. Click OK and click on the create rectangle. So the position is XWG over 2. Y iris. And the X size is minus X iris. And ZWG. Okay, now we already successfully created the geometry for the iris waveguide filter. Now, what I'm going to do is assign the boundaries for the left iris, right iris, and the waveguide box. So to click, you can control all, or you can click one by one here on the coordinate system here. Okay. So we click 3 of this. So to assign boundary, there are some methods. You can right click from here and assign boundary, or you also can go to the FSSS workflow here. From right click on boundaries, assign, and you can assign the boundaries, or you can go to FSSS here, go to boundaries here, assign. So for this boundary, I'll be using finite conductivity here. So it'll be the conductivity of 580 Siemens. And yeah, so we just click OK. Now you can see the boundaries have been created if you expand the boundaries. So you can see here are the finite conductivity boundaries that are being assigned. Now I want to assign the wave part. So to assign the wave part, you go to the select here. Instead of object, we change to face, and we click on the left side of the wave guide here. So to assign excitation, the wave part excitation, you can also, there are three methods, the same as we assigning the boundaries. So to assign excitation, and then we go to part and we go to wave part here and click next and finish. And you can see at the excitation on the HFSS workflow here, you can see the wave part already been created. So we want to create another wave part here. So we click on this face, and you can go to excitation, right click, assign part, and we click on wave part. We click on next and finish. Now we already create the parts. Then next, we're going to create the analysis setup. So wait. And for the analysis setup, the solution, we go to analysis, right click, add solution setup here, and we click on advanced. So the frequency we can we change to 10 gigahertz, and then the maximum number of passes is 6, and we maintain the maximum data as to 0.02. We click on OK. Then the frequency sweep will be appear. So for the sweep, we use the linear count. It start from 8 gigahertz to 18, with the number of points of 501, and we click OK. So you can see here the setup already created here. So before we start to analyze it, we need to, it's a good way before we start the analysis, we validate it first if there is an error. So if we validate it and everything is green check here, and we can straight away go to the analysis, and we right click it and we analyze it. So after we click analyze, the progress bar here will be appearing the progress for the simulation. You can see here, and you can see at the message center if there's an error. So we just need to wait. Okay, so it's a normal completion of simulation without any error. So now we can go and see the results. So to see the results, we can go to this result here, right click, create model solution data and rectangular plot. And we see the S parameter S11 and S12 here with a dB gain. And we click on new report. And you can see under the result here, the rectangular plot of S11 and S-perimeter 12 here had been created. And we also can see the electric field of the waveguide filter. So we click on the waveguide box. We go to field overlays, right click, spot field, E, magnitude E, and we click on done. And then you can see the electric field inside the waveguide filter here. Click on orange. We'll make it bigger. So now, after we create the electric field, we can make an animation for this electric field. So to do that, we expand the field overlays, the electric field, and make E1 here. We right click it and click on animate and click OK. So you can see the animation of the electric field. So with that, this is the end of the simulation demonstration. Now, if you have any question, you can ask now, and I'll be passing the screen to Zulaika for further instruction. Zulaika, you can take the screen.
Okay, thank you, Mr. Farhan. Before we move to Q&A session, I already launched a poll. Please select the appropriate response and click submit. Now, Mr. Farhan will answer the question. If you have question for the speaker, you may raise your hand and turn on your microphone. You also can submit a question via the chat features, and I will read your question. Does anyone have question regarding this webinar? For the poll, for those who have not yet respond, please go ahead and submit your response because we will close the poll in a few moments. And thanks for the feedback. I will quickly go through some points to note so we will all have a seamless webinar experience. Does anyone have question regarding this topic? So silent is me no. Thank you again, Mr. Farhan, for the great presentation. Mr. Farhan, is there anything else you wanted to cover?
Yeah, I think they all understand it very well. Yeah, I think I don't have anything more to cover. But if you have an extra, like if you have further question, maybe you can email me or something. Yeah, that would be wonderful.
Okay, great. Thank you, everyone. We appreciate you being here. Before we end, we also encourage you to connect with us on social media to get a latest information. For this video recording, you may get on our YouTube channel, DFE-Tech. So if you have additional question, you may contact us by email or telephone. We are happy to provide additional support. Thank you for attending. We hope you have learned and enjoyed this presentation. Have a nice day. Thank you again.